want to look at linear programming using the graphical method. And we have an example. A shop makes its meatloaf from a combination of lean beef and chicken. The lean beef contains 70% meat and 30% fat and costs $3 per kilogram. The lean beef contains 90% chicken and 10% fat and costs $4 per kilogram. How much of each kind of meat should the shop use in each kilogram of meatloaf if it wants to minimize its costs and keep the fat content of the meatloaf no more than 20%? We have the objective function, and that is we want to minimize cost, and we have our z function. So the first thing is we let x be equals to the weight in kg of lean beef, and then we let y be equals to weight in kg of lean chicken. We want to minimize z, which will be equals to 3x and 4y, because 1 kg of lean chicken will be equals to $4. And the decision variables is that we have x plus y is equals to 1. That means the quantity of x plus the quantity of y should be equals to 1 kilogram. And then the other thing we have is 0.3x plus 0.1y is less than or equals to 0.2. Or we had said that 30% of x plus 10% of y is less than or equals to 20%. So what are we saying? This is the fat content. This is the fat content into the product. Xy should be greater than or equals to 0. So that's the problem we have. So the first one is we want to minimize z is equals 3x plus 4y. Then on the decision variables, the quantity we take from beef plus the quantity we take from chicken should be equals to 1, because we are selling per kilogram. And then the fat content should not be high. So what we want to do next is we write down our mathematical program to minimize. Z is equals to 3x plus 4y, subject to x plus y is equals to 1. And then if I multiply there by 10, 3x plus y is less than or equals to 2. And the last condition is that x and y should be non-negative. So the quantity should be non-negative, and that's what we have. The next step is now I want to draw the graph. I know that x plus y is equals to 1. So what I get 2 points from the extremes, and that will help me to plot a straight line when I'm dealing with my graph. Is 3x plus y is equals to 2. And I have x and y. So when x is 0, y is 2. And when y is 0, x is 2 over 3. This is our graph. We have the feasible region and the infeasible region. And we have 3 sets of points. We have 1 point here. We have another point there. And we have another point there. This is the line x plus y is equals to 1. And therefore, we want to find out what are the values. For the first point, which we call point 1, the XY axis are 0 and 1. For the second point, this is where the two lines intersect, and it is a point where x plus y is equals to 1 and 3x plus y is equals to 2. Y is equals to 1 minus x, which tells us that 3x plus 1 minus x is equals to 2, and 2x is equals to 1, so x is equals to a half. If x is equals to a half, then y is equals to a half. So the second set of points, both of them, is that x and y are both equals to a half. Xy will be equals to 2 over 3 and 0. Therefore, we have our three sets of points. The point now is we want to find the set of points that minimizes, but we want to remember that it is said that we need to use each of the products, so we want to test the point. And z is given by 3x plus 4y. So in the first case, which is the set of point given by 0, 1, z will equals 3 times 0 plus 4 times 1, which is $4. And the set of points, the second set of points, which is a half, z will be 3 times a half plus 4 times a half, which is 7 over 2. And then the third case, and that is also in dollars, and in the third case, it will be 2 over 30, and z will be equals to 3 times 2 over 3 plus 4 times 0 equals to $2. Therefore, we find that the cheapest would be $2. But now, the meatloaf will need both x, which is the beef, plus y, which is the chicken. And therefore, the beef will be equals to a half, and the chicken will also be equals to a half, and the z will be sold at $3.5. So that is the minimum cost. The meatloaf requires half kg lean beef and half kg lean chicken at a cost of $3.5.